Okay, this is your exam debrief on part one. You took this in May. You're going into AP Calculus. You need to understand what you got right, what you got wrong, and why you got what you got wrong. So the first part is unit circle. A unit circle is the basic idea in trigonometry. We're asked to find the functional values for these 6 angles. Some are in degrees, some are in radians. Usually in AP Calculus, you'll be working in radians, but you need to be able to convert. Also follow directions. In the problem, it said it's recommended that you do not sketch the entire circle. I had many students spend 5-10 minutes drawing every single point on the circle. Instead, use quadrant 1 and symmetry to get whatever angles you need. Note by the by that if you're in quadrant 1, and you have an angle in standard position, like this, that the SOHCAHTOA relationship, the idea between opposite and hypotenuse, that gives you the various values for the trig functions. So here's a point, xy. Notice that this is the x value, this is the y value, and obviously the hypotenuse is 1 if you're on the unit circle. So when we say the sine of an angle is the opposite over the hypotenuse, the sine of the angle is y. And when we say the cosine of an angle is the adjacent over the hypotenuse, the cosine of the angle is x. And likewise, the tangent of an angle opposite over adjacent, y over x. So those relationships in the first quadrant work for right triangles, but they also work throughout the entire circle. So you need to know those definitions. The definitions hold for any of the angles that you need. Let's go and write those down. We'll do that down here. Let's see, the cosine of an angle is the x value, the sine of the angle is the y value, and the tangent of the angle is y over x. Some of the questions that were asked deal with the reciprocal functions. So the secant or the cosecant is the reciprocal of the sine, and the secant is the reciprocal of the cosine. We don't have a cotangent question in here, but yeah, you need to know the reciprocal identities as well. The secant is the reciprocal of this, and the cosecant is the reciprocal of this. If we needed the cotangent, it would be the reciprocal of y over x, x over y. Okay, let's go ahead and put the points in the first quadrant, get the angles sorted out, and then we can go ahead and attack the problems. So, okay, so first of all, the endpoints, you should be comfortable with that. This is 1, 0, and up here, this is 0, 1. Okay, the 45-degree line where the y and the x are the same. So here, x and y are both the same. They happen to be the square root of 2 over 2 and the square root of 2 over 2. So that's for 45 degrees or pi over 4, you can be able to convert. The 30-degree angle or the pi over 6, this is where the y is halfway up. So the y coordinate's a half, and the x coordinate is about 0.9. It's almost all the way over. It's the square root of 3 over 2. That's this guy. For the 60-degree angle, the pi over 3, that's where the x value is at the halfway point. So the x is a half, and the y is root 3 over 2. And that should take us, for all the points here in this first quadrant. And then by symmetry, we can get any other point that we need. Okay, so let's look at the problems. The first one says minus 30 degrees. So the minus 30-degree angle would be right here, right? So it's the same as the 30-degree, except it's going the other way. So the x coordinate's still the same, right? The x coordinate's still going to be the square root of 3 over 2. But now the y coordinate's going to be negative, right? Because we're going down instead of up. So minus 1/2. So the task was, what is the cosine of that angle? And the cosine was the x value. So square root of 3 over 2. I had a number of people write down minus, but x was negative, and it's not. Okay, tangent 3 pi over 2. So where are we on the circle? That should be a fairly easy one. This was, let's grab another color here. This was pi over 2 at the top, right? And this is pi over here. 180 degrees is pi. 3 pi over 2 is down at the bottom of the circle. Ordered pair, 0, -1. And we were asked to find the tangent of that. By definition, tangent is y over x. This is the y value, this is the x value. Well, we can't divide by 0, right? So if the function was undefined, the direction said write undefined. So what we should have done here is just write is undefined. That would be following the directions. Now I had a number of people, it wasn't marked wrong, but it will be next year or this year in AP Calculus. If you write this is equal to -1/0, that's an incorrect statement. So the tangent does not equal that. So if you start writing that, you should immediately realize, oh, that doesn't make sense. I should cross that off and then just go and write is undefined. Again, for examples in calculus, if you say a limit is 0/0, that's wrong. A limit is never 0/0. So if you write something like that, you need to erase it or cross it off because it doesn't make sense in mathematics. Okay, 180 degrees. Well, again, we're over here. Ordered pair, -1, 0. And what are we looking for? We're looking for the cosecant, which is 1 over the y value. The y value is 0. So again, is undefined. Don't write -1/0 or 1/0. That would be wrong. Okay, 7 pi over 6. Let's figure out where that might be. Grab a red marker again. 7 pi over 6. Let's see. Okay, so this is 6 pi over 6 coming all the way around. This is pi, 180 degrees. So 7 pi over 6 would be another 30. So we're straight across from this point. So think of going in the third quadrant. Instead of √3/2 and 1/2, we're at -√3/2 and -1/2. That's the ordered pair associated with 7 pi over 6. The task was to find the cosine. There's the cosine right there. It's that -√3/2. So -√3/2. Cosines are negative in the third quadrant. The secant of negative pi over 3. So once again, pi over 3 is a third of 180 degrees. So this is pi over 3 up here. So now we're down in the fourth quadrant, directly below this point. The x coordinate is going to be the same. We're still moving to the right 1/2. But now the y coordinate, instead of being √3/2, it's -√3/2. Okay, and so here's our angle coming like this. This is our negative pi over 3. And the task was, what is the secant? Well, by definition, the secant was the reciprocal of the x value. There's the x value, it's 1/2, and the reciprocal of 1/2 is 2. That's what you should have written there. If you had written 1 over 1/2 like this, that is the number 2, but that would not be accepted, right? Because the directions were pretty clear. Complex fractions must be simplified. So 1 over 1/2 is 2, and you needed to simplify that. The last one was the sine of -120 degrees. So once again, we're going clockwise, -120 degrees. So this would be -90, and -120 would be to here. It's the antipodal point from here. So it's symmetric about the origin from that point at 60 degrees. So -120. And again, the ordered pair, you can sort of see it. The x value would be -1/2. And the y value is almost all the way down, -√3/2. That's the coordinates that go with this point, -120 degrees. And we're asked for the sine value, right? The sine was the y coordinate, so -√3/2. Okay, unit circle problems. They need to go fairly quickly. These should not take lots of time. And notice that in my diagram here, I didn't draw anything in the second quadrant. If you drew a circle with points in the second quadrant, you wasted time. You didn't have to do any of those. Okay. Second page. Again, follow the directions. I had many students lose points because they did not follow the directions. Okay, factor the cubic expression x cubed plus 27 is a product of a linear and a quadratic. Start your answer with x cubed plus 27, then an equal sign, and then the two factors. So if you simply wrote down the x plus 3 and the x squared minus 3x plus 9, because you remembered how to factor that, you didn't get any credit, right? Because you didn't follow the directions. It said follow the directions. So to get a complete answer here, we needed to start with x cubed plus 27, then an equal sign, and then these two factors. Okay, so the linear factor and then the quadratic factor. Okay, number 8, the quadratic factor you wrote is called irreducible. I don't know that you need to know that terminology, but that's what it's called. It cannot be factored using real numbers. So this does not break up into two real number factors. It says we could break it up using complex numbers, but we didn't have complex numbers on this exam. Okay, the quadratic formula can be used to find solutions to quadratic equations. Complete the quadratic formula. So this is just simply, can you remember how this goes? So you needed to start off with x is equal to, and then that formula that's there. If you only have the minus b and plus minus the square root of b squared minus 4ac over the 2a. If you just had that component, you really haven't finished the conditional. Right? If this is true, then what can you say? Well, what you can say is that x is going to be equal to that. So you need to have the x is equal to. I mean, for example, if we had a slightly different hypothesis, let's suppose, just as a talking through this, if I said if k t squared plus mt plus n is equal to 0, then what can you say? Again, this is a quadratic formula or a quadratic equation. You should be able to tell me what the conclusion would be. Then t, not x, would have to equal, it's not going to be minus b, it's going to be minus m, right? Plus or minus the square root. It's not going to be b squared, it's going to be m squared, right? So the conclusion of this conditional, this if statement, really depends on the coefficients and the variable. So if kt squared plus mt plus n is equal to 0, then t is minus n plus or minus m squared minus 4 times k times n all over 2k. So yeah, be flexible enough to realize that this is a pattern that you needed to know. Okay, so for number 8, you needed to have the black there. Number 9. The discriminant is the part of the quadratic formula under the radical sign. So this is called the discriminant. Okay? Calculate the discriminant for the quadratic factor you wrote in problem 7. So we're going to be looking at the discriminant for this quadratic factor. Notice the a was 1, the b was -3, and the c was 9. And we're asked to calculate that. So let's see. Start your answer with b squared minus 4ac, then an equal sign, and then the correct substitution and simplification of the expression. Okay, so the b value was -3, was it? Yep, b was -3, so we have -3 squared, and then -4, and then the a value, which was 1, and then the c value, which was 9. Okay, so this is what you should have written. I had a number of students lose credit because they wrote this, -3 squared minus 4 times 1 times 9. Okay, so this is wrong. This says the opposite of 3 squared, which would be the opposite of 9, which is -9, and yet we were supposed to square the negative 3. So negative 3 times negative 3 is a positive 9. So even if you wrote this, right? So, you know, if you wrote this line right here and that, it's wrong because this does not equal 9. So no, you needed to have that 9 minus 36 and subtract that out and get minus 27. Okay. The original cubic expression appears in this equation. This equation can be solved by factoring, then setting each factor equal to 0, then solving each of the simpler equations. It says use only real numbers. So no complex numbers for this particular problem. So let's see, we have x cubed plus 27 is equal to 0. We know how to factor it. X plus 3, x squared minus 3x plus 9 is equal to 0. There's an important key here. You do have to write this as equal to 0, and you have to write this as equal to 0. So we have these two factors multiplied together with the 0 product. One of them has to be 0. So x plus 3 has got to equal 0. Or this one over here, x squared minus 3x plus 9 has got to be equal to 0. And then it said to solve each of those simpler equations, right? So if x plus 3 is 0, then x is negative 3. And if this is equal to 0, we've already saw that it has a negative discriminant, so no real solutions over here. Right? Because if we tried to attack it with the quadratic formula, we would have had this part is a negative 27, and you can't take the square root of negative 27 in the real number system. Okay? And the last problem here was again dealing with this equation, x cubed plus 27 is 0. We rearrange it as x cubed is equal to minus 27, and then solve it as a power equation by raising both sides to the same power, right? So we should use the reciprocal power, which would be 1/3, and then negative 27 to the 1/3. Okay. Simplify, again, using real numbers. So this is simply x to the first. This is the cube root of negative 27, and the cube root of negative 27 is negative 3. I had a number of people say you can't do the cube root of negative 27. Of course you can. I mean, think about the cube root function. The domain is all reals, right? So yeah, you can come out here to negative 27, and there's that ordered pair, negative 27, negative 3. Cube root of negative 27 is negative 3. Okay, next page. So it says to circle the letter of the correct choice. Now we didn't take off for this, but you know, follow directions, folks, follow directions. If you circled this for this problem, you didn't follow the directions. I don't think we marked it wrong, but again, it says circle the letter. So what you should have done for this problem is just done this. So look at how you answered and see whether or not you followed the directions. Learn to read and follow the directions. Okay, we have a point where x and y are the same, and we're trying to figure out the r and the theta value. I've already given you the answer here. If you think unit circle again, where x and y are the same, y equals x is this 45-degree line. Right? This is where y is equal to x from your library of functions. And this point on the unit circle would be square root of 2 over 2, square root of 2 over 2. This is a little bit further away, right? It's twice as far away. It's just the square root of 2 over square root of 2. But it's pretty clear that x and y are the same, so we have to be on this line somewhere. And so pi over 4 is the angle. That's not right. Because just by process of elimination, you know the choice is E. If you just wanted to verify that the r value was 2, you could draw a little triangle, right? So the x value was root 2, the y value was root 2, and the hypotenuse, h. You just use Pythagoras here. Square this, you get 2. Square this, you get 2. 2 plus 2 is 4. Square root of 4 is 2. Yeah, so we do have a hypotenuse of 2 instead of 1. This looks like a scary problem, right? Because you don't have a calculator. There's a ton of decimals here. You're told that 4 of these are correct and 1 of these is wrong, and you got to figure out how to do that. Okay. So it does say think of either the graphs or the permissible values of the trig functions. Holding off on that just for a second, this is a very similar type of problem. here it says, given an angle, if the tangent is positive and the cosecant is negative, where does the angle have to be? So this might recall that whole idea of all students take calculus, right? Where all the trig functions, sine, cosine, tangent, and their reciprocals are positive here in the first quadrant. Only the sine and its reciprocal, the cosecant, would be positive in the second quadrant. The tangent and its reciprocal, cotangent, would be positive down here, and the cosine and its reciprocal, secant, would be positive in the fourth quadrant. This says the tangent is positive, so we have to be dealing with either here or here, right? And the cosecant is negative. Well, all functions are positive here, so we have to be dealing in quadrant 3. So quadrant 3 would be the choice for number 14, right? Quadrant 3 between pi and 3 pi over 2. Going back to the previous problem, if you start to think about how these things play out, you might eventually stumble across the fact that this angle, this 92-degree angle, is in the second quadrant. So, you know, a little sketch. 92 degrees is about like this. And it claims the cosine is a positive value. Well, that can be right? Because the cosine, if you're on this terminal side, the cosine is going to be negative. The x values are negative going this way. So this, in fact, is the one that is incorrect. The other ones, if you try to sort of reason through there, there's no reason why you would think they would be wrong. So 36 degrees is about like, you know, so here's my unit circle. 36 degrees is about like that. It looks like the y coordinate's about a half. That's okay. 94 degrees, we're up here. So 94 degrees, like that. Cosine's pretty small, right? It's a negative small number. I don't know, negative a seventh, something like that. And the secant is the reciprocal of that, so the reciprocal of a negative small number is a negative big number, right? Negative 14. So that seems reasonable. This one we know it's wrong. 281 degrees, where is that? Oh, there's 90, 180 degrees. 270, 281 is down here somewhere. Okay, so it says the tangent is a negative number. Okay, tangents are positive over here, tangents are negative over there. Y 5-ish. I don't know, maybe the y value coming down is much further away than the x value. So y over x might be negative 5. In fact, that is a correct value. And lastly, the sine of 309 degrees. 309 degrees is, again, way over here in the fourth quadrant. The sine is a negative, and that seems to be reasonable. Okay, so that takes care of that. Last page, and then we'll shut down this video. These are free response questions. They're worth 4 points apiece. So a lot of credit in here, a lot of partial credit in here. Starts off by sketching a graph of a sinusoid, right? This is a sine wave. Sines go through the origin, you needed to know that. So I would start at the origin, sine. The amplitude is 2, right? So we're going up to here and down to here. But the negative sign means that we're upside down. So the normal sine wave goes like that. So this one's going to be going like that. So we're going down into the fourth quadrant to start the wave. How about the period? So you needed to know the period. The period for the sinusoids is 2 pi divided by b, where b is this multiplier of the angle there. So 2 pi over 2 is pi. So we get a full cycle, full wavelength, a full period between 0 and pi. And so let's think how this has to play out. We know the wave is going to go down, it's got to come back up, and then it comes down. So there's a crossing here. This is a low spot, this is a high spot. So here's one cycle of this wave. And if you did that, you probably got 3 out of 4 points. So you've got everything sort of sorted out right. But it does say you have to graph over the interval from negative 2 pi to positive 2 pi. So we need 4 cycles here. So another cycle, grab another color just for the heck of it. Another cycle going from here to here. Okay, so down and up. And then another cycle over here. We're not going to be super critical here, but if you had this idea, if you gave me this sketch, you would have gotten full credit. Okay, so there's 4 cycles, 4 wavelengths of this particular problem. Okay, learn the graphs of the sines and cosines for sure. You should also be familiar with tangents and such, but certainly the waves. Last problem, no calculator. Solve the equation on the interval 0 to 2 pi. So think in unit circle, we're going once around. And it tells you how to do that. Set each factor equal to 0. It's already factored, which is nice. So we don't have to factor it. Just set each equal to 0, solve the 2 simpler equations. 4 points, 1 for each of the 4 solutions. So there should be 4 answers. X will be something, 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 right? That's the task. So let's see how this would play out if we were working this problem. We start off with 2 sine x plus 1 times cosine squared x minus 1 is equal to 0. So we have 2 factors equal to 0. This could be 0. 2 sine x plus 1 is 0. Let's go ahead and finish this one out. We get 2 sine x is equal to negative 1, moving the 1 across, and then dividing through, we have sine of x is minus 1/2. And to finish this, we would have to figure out where does that occur on our unit circle. Not terribly difficult to do. I would draw a little sketch and say, okay, the sine was the y value, and the y value is halfway down, negative. So we're here, and we're here. We needed the 2 angles. So one angle comes all the way around like that. X could be 7 pi over 6. The other angle would come all the way around to here. So X could be 11 pi over 6. You could not say a negative pi over 6, right? I mean, it's true that negative pi over 6 would be coterminal with this, but the directions say you had to solve for x's between 0 and 2 pi. So no negative solutions. Okay, so that's that first half. And then for the second half, we're going to do very similar, right? So we have cosine squared of x minus 1 is 0. So cosine squared of x is equal to 1. Now here you needed to know a little bit about notation. This cosine squared of x means this. It means the cosine of x quantity squared is equal to 1. So we have this power equation here. We're going to take the square root of both sides. So whenever you take the square root of both sides, you need to do plus and minus, right? So now we're going to have the cosine of x is plus or minus the square root of 1. So the cosine of x could be plus or minus 1. Again, go to your circle. Cosine is 1 over here at the right side, and negative 1 over here. So x is 0, and x is pi. Those are the 4 solutions to that particular equation. So it was a little bit of unit circle stuff, and the idea of setting factors equal to 0. And by the by, just this coming year when you're doing the AP Calculus, if you don't set that equal to 0, chances are, even if you end up with the right answer, so let's say we just wrote that down and then somehow we ended up this, in all likelihood, you would not get any credit for those answers coming from that, because you didn't say what that was equal to. You would have to say this is equal to 0. Then you can jump to that, and then you'd get credit. Okay, I'll do the calculator portion on another video. This one's taken almost a half an hour. See you then.